Hey everybody, welcome back. So I didn't post a video on Friday. I apologize. I had to cover for a class. So yeah, but I'm back. The plan is to get through these no later than the end of the day tomorrow. So hopefully we will have finished all the remaining problems with the spring 2019 MCAS. And yeah, we got about a week away. So hopefully everybody's studying, working hard, and I'm hoping these videos are helping you. Let me know, by the way, if they are helping you. Or if there's things that you don't like about the videos, let me know. I can make them better for you. So, yeah. All right, so anyway, if you're watching this for the first time, there's a video description, and in that video description there's the link to the digital test. You should have, basically the plan is you take this first digitally, you try it, and then you watch the video, okay? And that's how it works. There's also a PDF in the description that's what this is, okay? All right, so let's get right to it. This is number 23 in the spring 2019 Math MCAS. So a travel agent surveyed people in two age groups about whether or not they like traveling. Some of the results of the survey are shown in this two-way table. Drag and drop a number into each box correctly to complete the table. Each number may be used once, more than once, or not at all. Okay. So this is a really interesting problem. Two-way tables, we're typically deciphering them and reading them and getting information out of it. This is a partially completed two-way table, where you have to plug it in, like plug in the numbers to make it make sense. I don't know if you guys have ever done those logic problems where they have like categories, like, you know, 5 different people that like 5 different types of plants, and they have 5 different colors, and they tell you things about each person, and through process of elimination you figure out who likes what, and it's actually set up in a very similar format to this. If anybody knows what I'm talking about, it's a great analogy. If not, you're like, what's he talking about? But anyway, yeah. There's two age groups here. There's ages 18 to 30, and there's ages 31 to 60. And they ask who likes traveling and who dislikes traveling. And they give us one of the 4 results, but they do tell us all the totals, okay? As you can see, they asked 50 people from this group, right? Total 50, and 50 from this group, okay? So we know that. So we know there's a total of 50. So straight away, if you figure out that this is 50, you can immediately figure out what this would have to be, right? So we know there's 50 total people in this group. We know 10 dislike traveling. So if 10 dislike it, that means the difference would be the amount that likes it. So you do 50 minus 10 is 40. So 40 people like to travel, okay? All right. Now, again, there's different ways of solving this. You could solve this now or this one. I'm going to go ahead and solve this one. So we're told that there's 40 people that total that dislike traveling, and there's 60 that like. Okay, so 40 dislike it. 10 of them are in this age bracket. That means the difference would be this. So we do 40 minus 10. And 40 minus 10 is 30. And this makes sense because 10 plus 30 is 40. This is a total. All right, 40 plus 10 is 50. All right, and now this last one, you can solve it either way, either vertically or horizontally. Let's go vertical. So we're told 60 people like traveling. 40 of them are in this age bracket, and that means the difference would be here. So we're going to do 60 minus 40, and that's 20. And that makes sense because 40 plus 20 is 60. 10 plus 30 is 40. And this makes, let's double check it. 40 plus 10 is 50, 20 plus 30 is 50. Yeah, this works. It's interesting that slightly proportionally, it looks like as people get older in this study, they like travel less, which is interesting. Anyway, so that's it. It's pretty straightforward. I think this is actually a really cool problem. I like this one. All right, this is number 24. This is also a very interesting problem because most of you probably know this topic very well, but the way it's worded can be confusing. So this is asking us, 24, which of the following graphs does not represent y as a function of x? That's the important word. If this was just asking you which of these is a function, I think 99.9% of the students would immediately remember, oh, vertical line test, or what does a function look like? Are the, you know, is there a one-to-one relationship between every x and y value, right? But it's not the way it's worded. It's worded as which of these does not represent y as a function of x. It's asking you which of these is not a function. Okay, that's what it's asking you. These 3 are functions. You can tell because they pass the vertical line test, right? There's a one-to-one relationship with every x and y. However, here, this is not a function, right? Vertical line test fails. Look, these both have the same x value, right? Okay, pretty straightforward. So D would be the answer. But it's just the way it's worded, I think, is confusing for a lot of people. Now this one's kind of hard to show you in written format because it's really dependent upon the digital format, but I'll try to explain it as best I can. It's saying that square EFGH will be reflected over the y-axis. Graph the image of square EFGH after the reflection. So the image is what you get after you apply a transformation. Technically this is the pre-image. The resulting figure would be the image. So if we're reflecting over the y-axis, it's flipping this way, right? So that means the x values would change signs. But you can just count the squares. This is 1 this way, it'd be 1 that way. This is 1, 2, 3, it'd be 1, 2, 3. Same thing here, and same thing here. And at least the nice thing about this one is you don't have to worry about assigning the letters, the vertices. I think I do it on this side, yeah. So technically it should look like this. And when you plot these, it allows you to plot the points, and once you plot the 4 points, it creates the square for you. And you don't need to worry about the vertices. Like, you don't need to worry about labeling this as like E prime, F prime, G prime, or H prime. You don't have to worry about that at all. Okay, that was number 25. Okay. Yeah. All right, number 26. Okay. So this is an interesting one. It's asking us to find the perimeter of a parallelogram. So the perimeter is the length around a shape, right? So we want to know the length of these two legs, and these two legs. Well, I shouldn't say legs, these two sides, okay? We're told that each block is a unit. Now you can tell these are diagonal, so you can't just count. Like, you can't do 1, 2, 3. It doesn't work like that. If they're vertical and horizontal, we could just count the squares. But it's not as easy as that. So what we're going to do is find it by creating triangles. So here's a triangle, right? Specifically, we're going to make a right triangle. Okay, I'm going to zoom in a little more here. All right, so let's go ahead and make a triangle here. So this is 1, 2, 3, 4, and this is 1, 2, 3. It's a right triangle, so we can use the Pythagorean Theorem. It's kind of hard to see that 3, sorry. We're gonna use the Pythagorean Theorem to find the missing sides. We're going to say a squared plus b squared equals c squared. This will be our a, this will be our b. It's really hard to see that. Oh well. 4 squared plus 3 squared equals c squared, and this is our c right here. Okay. So 4 squared is 16, and 3 squared is 9, and we're going to add those together and get 25, and that's c squared. And now we're going to square root both sides because we want c, not c squared. So c would be 5. So this would be 5 units long. Okay, so 5. And I believe this is the same thing. It should be. It's a little easier to see that. So 1, 2, 3, 4. 1, 2, 3. Yep. So this would be 5. So we have these two. Oh, I was off screen. Sorry. Now we need to find these. This is a big triangle. Wow. Okay, so we got that one. I think it's easier to see the blue, actually. Yeah, it's a little easier. All right, let's count. We have 1, 2, 3, 4, 5. I'm going to kind of draw an arrow so you can see a little better. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12, this is 5. We're looking for this diagonal side. So again, we're going to do a squared plus b squared equals c squared. So 12 squared plus 5 squared equals c squared. That's 144 plus 25 equals c squared. Add these, I'm off screen again, sorry. Add these together, 169 equals c squared. And we're going to square root both sides because we need c. And square root of 169 is 13. Okay, so this is 13. This is the same triangle here up top, so this would be 13 as well. So let's add these together for the perimeter. So we have 13 plus 13, right, these two sides. I mean these two, so plus 5 plus 5. So 26 plus 10, 36. And it should be B. Let's zoom in a little more. There we go. Okay. So this one's really all about Pythagorean Theorem. That's really it, because it's the only way you can find out really the only reliable way to find the length of those sides. Okay, 27. So for this one, you'd want to go to the reference sheet, which is part of the exhibit. Okay. This one can be tricky if you don't use your calculator, so make sure you're using your calculator on this one. This should have been part of the calculator section. Let me pause and grab a calculator, actually. Okay, so a sphere and one of its dimensions are shown in this diagram. They give us this. Now, the only thing that sucks about this picture is that because the way they drew it, it doesn't make it obvious to whether or not it's diameter or radius to some students. This means the diameter, okay? This is saying that the diameter is 13, not the radius, but I just wish it was a little more clear on the way they did that. Which of the following is closest to the volume of the sphere? So the first thing you do is click on the exhibit button, which is on the right-hand side of the screen when you're looking at the digital, which you should all already have done this at this point in terms of getting comfortable with the format. If not, please do so, right? So you click on exhibits, there's a little box on the right, and then reference sheet will pop up. And you look for the volume section, and the volume of a sphere is 4/3 pi times radius cubed, okay? Now we don't have the radius, but we do have the diameter. And we have to remember that the diameter is just 2 times the radius, okay? So this is double the length of the radius. So we take 13, divide it by 2, we're going to get 6.5. And that's going to be our radius in this case, 6.5 inches, okay? So let's plug these in. We're going to have 4/3 times pi times 6.5 cubed. Cubed. That looks like 2 now. There you go. And then we just have to do this calculation, and it's going to be closest to this, right? So it looks like they didn't keep pi in terms of pi. They kind of just estimated, which means they probably used 3.14. So anyway, even though I hate it when people, well, I shouldn't say 3.14, 3 and 1400ths, I guess. But I hate it when people, I like when people just leave it in terms of pi, because it's the most accurate way of doing it. It's my math OCD kicking in. All right, so let's figure this out. So 6.5 to the 3rd power. All right, you all see that? And that gives us this value right here. So we're going to get 4/3 times, yeah, I guess we're going to estimate that, times 274, 625 thousandths. Now we just simplify this. So we're going to say this time, I guess we'll do 4/3. We're going to multiply that by 3 and 4. And then we're going to multiply that by 274 by 625. Okay. We're going to get this ugly number, right? Which is awfully close to that. Now, if you didn't have a calculator, closest to, right, that is typically meaning estimation, right? So let's just estimate some of these values. Like this one you could do by doing 6.5 times 6.5 times 6.5. Okay. And this is what we got. Let's just do an estimation version of this. So 4/3, and let's just change it to 3. Okay? And we'll change this to 275. Okay? So the 3's would cancel and be 4 times this. So the 4 times 275, and 28, you can get 30, 8, 11. So yeah, it's obviously not as close as what we got before, right? But it is closest to that, so you'd still get it. Like, so if you estimate it very roughly, I mean, like it's very inaccurate. But if you didn't have a calculator, you could just estimate this. Once you did this, you would have to multiply that out. You would have to say 6.5 times 6.5 times 6.5. You could do that, which does take some time actually. Yeah, but that would be the hardest part without a calculator for a lot of students. Actually, just multiplying 6.5 times itself 3 times. So anyway, there you go. Number 28. Okay, number 28. This table shows the values of the linear function f of x for different values of x. So here's a table, right? X is 0, f of x is 120. X is 20, f of x is 90, and so forth and so on. As x is increasing, the functional value is decreasing, right? So you can tell, you know, it says it's a linear function, so it's a line, right? You can imagine it going down from left to right. Here's the y-intercept. You can see, right, when x is 0, the y-intercept is 120. Okay. The function g of x is represented by this equation. It's also another linear equation, right? We have our rate of change, we have our y-intercept. Compare the rates of change and the y-intercepts for f of x and g of x in this table. Okay. So which one has the greater rate of change? Well, they don't tell us the rate of change here, but we notice that the functional value is decreasing, the y value, this is really the y value, right? But the functional value is decreasing as x is increasing, which means it's going down from left to right, which means that slope is negative. It's a negative value, right? You don't even need to know what it is. Like I think it's negative 15. Let's say down by 30. No. What is it? Oh, now I want to know what it is. Why not? Let's just do it. So let's do let's do x1, y1, and x2, y2. Let's just do it, why not? So 90, let's remember y2 minus y1 over x2 minus x1. So this is how you can figure out what exactly what the rate of change is. Let's just do it real quick, why not? 20 minus 0, so it's going to be negative, no, it's negative 3. It's negative 3 over 2, that's what it is. So negative 30 over 20, simplify that, negative 3 over 2. But you can tell it's negative. My point is you don't even need to find out what the exact slope is. You can tell it's negative, right? That's my point. Here it's positive 10. So clearly this is a positive slope, which means it is a greater rate of change because it's positive versus negative. So g of x would have the greater rate of change. But if you want to find out what it is, you just plug in x1, y1, x2, y2, and calculate it, like we did here. Which one has the greater y-intercept? Well, this is the y-intercept here, because remember y equals mx plus b. It's our slope-intercept form. So this is the y-intercept of 40. Here, when x is 0, our y-intercept is 120. So that clearly has a bigger y-intercept than this one. So f of x has the larger y-intercept. Okay? And that's it for number 28. This one can throw people off because there's a lot of information, but there's actually very little you need to do to solve it, right? As long as you understand how to recognize what a slope or what a rate of change is by looking at either a table or a linear equation, then you're good. Similarly, as long as you can recognize what a y-intercept is by looking at either a table of a linear function or also an equation that's in slope-intercept form. Okay? Okay, number 29. This is actually testing a similar skill strand right here. A factory worker loaded some boxes onto a cart. Each box has the same weight. This expression represents the total weight in pounds of the cart and the n boxes. So n is the number of boxes. Okay. Based on the expression, which is the weight in pounds of just the cart by itself? Okay, well, n is the number of boxes, right? If this is the number of boxes, the reason we have a 10 in front of it is because each box weighs 10 pounds. Right, it's 10 times the number of boxes, that'd be the weight of the total boxes. This is the weight of everything else. In other words, this is the cart. So it's the cart plus the boxes weight. This would be the boxes. So the weight of the cart would be 25 pounds. Again, this is asking you, hey, do you understand how to identify the y-intercept? Because the y-intercept in many ways can be viewed as the starting point for many functions, because most linear relationships we work with start with an input of 0, right? So if n is 0, if there aren't any boxes, this is just the cart. It weighs 25 pounds, right? So it really takes just practice. When you look at a linear function, you understand what each element is, right? So that's going to be it. This is number 30. We're going to do a video for 30 later. So let's just do a quick recap. Let's go back a little bit here. So we got to 29. That's not bad. I'm going to try to do a video for 30 and post it before the end of this period. So 23 was a two-way table. We had to be able to decipher which numbers would plug in, right, by just using the totals. All right, wasn't too bad. This one's asking if we know what a function is. Can we recognize what a function is and what a function does not look like? Number 25 asked us if we could apply a transformation, just a simple reflection, by posting what the reflection of what the resulting image would look like. 26 asked us to find the perimeter of a parallelogram, and the only way to do that was to use Pythagorean Theorem. This one probably required the most work, the ones we did. Number 27, we had to estimate what the volume of a sphere was by using the formula they gave us. And we also had to know that even though they give us diameter, we need to use that to find the radius, which is half of that. Okay. This one, we had to identify which of these two functions has a larger rate of change and which one has a larger y-intercept. And this one, we just had to identify the weight of a cart, which is really the y-intercept. This one might be the hardest one, even though it requires the least amount of actual math. I think this one might be the most confusing for a lot of people. Let me know, actually. Let me know which one was the most confusing for you. I'd be curious. All right, guys, thanks for watching. I hope that was helpful, and I'll be posting the rest of these very soon. Thanks.